first alloy is in 1100, and you see in a couple of seconds. So this first alloy is in 1100, and you see in a couple of seconds 1100. You know, you can do that repeatedly. We'll shoot the same thing again, 1100. So we pull the trigger, a couple of seconds, there you go, 1100. Now we move on. Now we move on to, let's say, a 6061. Pull the trigger. There you go. A couple of seconds. It says 6061, a perfect match. One of the keys to measuring 6061 is measuring the chrome concentration. As you can see on the display on that 61, the chrome is about 0.04%, right at the low end of the chrome range in 61. This is something, if you don't measure that, if you can't detect that chrome, you cannot really say that's a 6061, because that is one of the key differentiators. And this is a big deal between the argon systems and the air-based LIBS units. That chrome ranges between about 0.04 and 0.2%. It's typically on the low end in 6061. And if you don't measure that, you really shouldn't be calling that a 61. So, and again, with the argon, you can get that much lower sensitivity. You can pick up that chrome in just a few seconds, as we showed. Then moving on to the third alloy in this little group is 6063. Pull the trigger, again, a couple of seconds, up comes 6063, as you can see. Right? And we'll shoot that again, because just to show you why that was identified so quickly. 6063. The reason being, see, it's a perfect match of a score of 100. The key is that magnesium. In a couple of seconds, we measured that 0.5 or so % magnesium in 6063 versus a 61. Let's measure that. As you see in a 61, the magnesium is up around 0.8%, 0.9%. So that's the real difference. You see that difference in mag. You see the chrome and the copper in 61. And that's how you know it's a 61 versus a 63 or an 1100. So this is a 7050. And the key to separating these two alloys is a little bit of zirconium. So here's a 7050, and you see down at the bottom of the screen, this says about 0.16% zirconium. That's critical. You have to measure that zirconium to separate those two alloys. So that was a 7050. Where's my, take my 7075, which this will say 7075 because as you'll see, they won't measure the zirconium. There's your 7075 in just about a second or so. And if you look down the screen, way down, someplace there it says zirconium not detected. And that's the real difference. You have to see that 0.1% zirconium, or you can't separate these two critical aerospace alloys for aluminum. And again, you need that argon purge to be able to see that low level of zirconium. Without that argon purge, there's no way you'll measure that. There's no way you'll really separate these two alloys in a reliable fashion. .2024 is, again, it's ubiquitous. You'll see it everywhere. It's a high copper aluminum alloy. A few seconds, it pops up 2024. What we've seen a lot in some facilities is, especially that rely on X-ray, is mixing up 2024 and 2014. This 2014 aluminum alloy is almost identical to 2024, except it has a much lower percentage of magnesium. So when I shoot 2014, which you'll see in a second, up comes 2014. And if you look at the two tests, you'll see 2014 here, the mag was about 0.7%, easily within the spec. If I go back and shoot 2024, you'll see the mag comes up around a little over 2%, and that's typical. So that we see that was mixed up a lot, especially in recycling facilities where the X-ray doesn't measure the magnesium well enough to separate 24 and 2014. So 3003 is probably the most common 3000 you run into in most facilities. And it's pretty easy to pick out. As you can see, it comes up quickly, and the key is that 1% or so manganese that you see up there. So there you go, see it's 3003, perfect match. If you scroll down to magnesium, you see that's very low, down around 0.02%, which there's really no spec to magnesium in a 3003. However, you go over to 3005, and the only difference between these two alloys is that 05's got higher magnesium, but the same manganese. And again, this is something that X-ray has a real problem sorting quickly. But you see in a few seconds, there's 3005. You've got your manganese up or over 1 as normal, but you've also got your magnesium now up around 0.5%, which is right. Spec to 0.2 to 0.6. A feature of the LIBS unit is that it can measure lithium actually very quickly and very well. And we see those. So here's a piece of aerospace scrap. And the grade, I don't have a specific grade in here, but the key to remember there is you're seeing your 1% or so, 1.2% lithium. And there you go, 356 in a couple of seconds. So about 7.5%. So let's start out with 6063, which is probably my lowest mag containing alloy. This is around 0.5%. And the focus here, I mean, if IDs degrade correctly, the focus here is the mag content. So about 0.5% there. So a few seconds, you see 0.5. You go to a 61. In a few seconds, you see this is up around 1%. And then you go to, say, 5052, which is around 2 or 2.5. There's your 52, up around 2.8 or so. And then you go to a really high one, another 5,000, that's up around 5 or 6%. Your 5083. So the point there is in a few, if you really are trying to just sort out by mag content, LIBS with argon is a great technique. As we showed in a few seconds, we did 0.5%, 1%, couple percent, 5 or 6%.